So my name is Marc Jankowski. I work for NTT Phi Labs, and I'm a research scientist doing nonlinear optics. If you imagine that you're like plucking a guitar string, if you pluck it harder and harder and harder, it doesn't just get louder, it starts to sound different. And the reason that it sounds different is that you're exciting some overtones of the frequency. That's basically what nonlinear optics is. Light is also a wave. It's also described by a frequency. If you were to put a laser through a crystal and make it very, very intense, it turns out that you can excite some of the overtones of that light, so you get different colors out. There was this experiment where they generated this light source that you could pack so much information into that you could send the entire bandwidth of the internet down just like a single optical fiber. You know, that's an example of nonlinear optics opening up just totally new applications, like something that you wouldn't have thought of doing 10 years ago. The thing that we're focused on right now is the computers, because there's an obvious demand for it, and society is kind of hitting its limits, where we can't imagine having much more efficient processors, and so we need totally new ways of approaching computation. Being able to access these new types of computers, in principle, will give us the ability to predict new medicines, new materials, new chemicals, potentially new ways of sending and receiving information. All those things are possible.